coordinating by Dr. Mayank Sharma sir, and other members and students who are all present here. Without wasting time, just I want to say that due to last year, due to this pandemic, when we used to use uh, live series by exchanging our views, opinions, due to pandemic, we have to go through this e-mode, means this Google Meet and Geo Meet, this all platform came. But anyhow, so first of all, we have to carry on our life with adjusting with the pandemic. So that's why presently we are on this platform. Otherwise, it would have been better if we have face to face some interaction and whatever the lecture series. So this my I am presenting here you primary cycle heat exchanger, nuclear primary cycle heat exchanger. Basically, you know that in nuclear power plant, I am audible. Hello, am I audible now?
Yes, sir, you are audible, sir.
Okay. So
Yes, sir,
basically,
it's fine, sir.
okay,
You are audible.
in nuclear power plant, whenever we go, there are two cycle. One is called primary cycle and one is called secondary cycle. So presently in India, whatever resources we have, so we are concentrating on secondary cycle equipment. Nuclear secondary cycle and thermal cycle each same almost. In nuclear power plant, secondary cycle equipments are your turbine, condenser, LP heater, HP heater, and your thermal cycle also. We have turbine, condenser, HP heater, LP heater. But basically, what in nuclear power plant, it's one reactor core is there. So whatever all those equipments near to reactor, it is called primary cycle equipment, nuclear reactor. So various type of primary cycle equipments are there. Your steam generator, like primary cycle equipment, which is nearest to core, reactor core.
Yes, yes.
And various type of other heat exchangers are there, like for which I will explain you about the related to primary cycle heat exchanger, which are using for nuclear reactor core. And these heat exchangers are very critical for any power plant, because what will happen, suppose when we used to manufacture this type of equipment, our customer, Nuclear Power Corporation of India Limited or BARC, they used to say that you please prepare this equipment at least without shutdown. There should be 40 years life of the equipment. Normally in the thermal power plant, which we have seen in your state electricity board and whatever presently now, so there what happened, actually, if suppose shutdown is there, we can change the heat exchanger. Suppose heat exchanger, some tube bundle repair is required, without any interference we can go and we can sort out the issue at the site. But in the nuclear power plant, it's means the near reactor core, whatever equipment is there, we have to once shut down means we have to erect it very carefully. Otherwise, so much damage, radiation, you have seen that any nuclear radiation, if suppose came, it becomes a hot issue. Means zero tolerance limit is there. So it's not like that मतलब चल जाएगा जुगाड़ in while manufacturing of nuclear primary cycle heat exchanger. It is not possible. In the front screen, you might have seen that this is heat exchanger, these tubes, and this is in clean room. Clean means for preparing nuclear primary cycle heat exchanger or steam generator. For this tube insertion, bundle insertion, we have to done in clean room. Clean room is what? It should be dust free enclosure. No dust should be there. Suppose we are inserting tubes also, we have to use gloves, because for maintaining 40 years of the equipment, it should be that no dust should be there, proper cleaning should be there. What whoever personnel used to inside this clean room, they should wear gloves and apron very carefully, and we have to maintain temperature, humidity, So this type of equipment normally and in foreign countries they used to ASME guideline. Normally in the thermal cycle we don't follow that much stringent condition. With normal shop floor we are preparing heat exchanger. Whatever this activity you are showing in this clean room, it can be done in normal shop for your HP heater, LP heater, thermal cycle power plant. So now uh, BHL Bhopal is preparing primary cycle heat exchanger. BHL Trichy is preparing steam generator. So these are all primary cycle equipment, and reactor core L&T is preparing, or any foreign vendor. And beside that, all subsidiary BHL is preparing. So I will concentrate on how what is the features of primary cycle heat exchanger, what is the what points, important points we have to deal while manufacturing or while designing, while engineering, we have to follow this for this heat exchanger. So let's start my first slide. So I already told you this in the screen it is landed primary system. This is for primary and this is for critical. And fabrication, what work we have to follow here: ASME section 3, NB, NC, ND, and NF requirement. What is this section 3 NB each for class 1 component? Section NC each for class 2 components. Means in this section, what is from raw material to inspection, testing, how it will be there. Suppose for example I am taking baffle plates. Suppose we some manufacturer will supply us plate. So for that place in ASME section it is written what type of test are required before using this plate for fabrication. So ASME section has some certain guidelines. If this test will pass, then only we can take plates for drilling. So what engine they have to refer this spec, and they have to prepare the specification, technical specification by reading ASME section 3, NBC, NG, and what are the requirements. And this is very highly skilled and qualified job. Means it's not like that somebody in this in thermal cycle means anybody can do. But this is what for this primary cycle, if every operator is critical, because suppose I am taking drilling might you all know. For drilling also, that fellow has to qualified, then only he can start drilling. Otherwise normally in thermal power plant what we used to do, okay, we will see the drawing and we will start drilling operation, and we'll check as per drawing requirement, okay, then we will accept it for thermal power. But for nuclear power plant, if suppose you have to drill also, you have to qualify the manpower, you have to qualify the machine, you have to qualify the fixture, you have to qualify even the coolant also. Coolant, because coolant sometimes their sulfur and chlorine content, you might be if suppose it is less than more than 25 ppm, then in with reaction that life cycle of the equipment will reduce. So thinking in mind 45, so we have to use special lubricants. Means sulfur halogen should be less than 25 ppm, and sulfur should be also less than so. And thermal, we won't see with just a normal lubricant, okay, some brand will come, we will do it. But here also and suppose in baffle drilling we used to use lubricant plus oil, some plus water. For thermal projects we are using normal water and this coolant, but here we have to use DM water plus coolant, then we have to start drilling. So these are the, so many stringent requirements are there, then only we can achieve the requirement of nuclear power plant. Means they are designing heat exchanger by means by following every minute critical activity, then only this heat exchanger can sustain at that temperature and at that condition near to reactor core. So my next slide is just I told that class 1 components that are primary core cooling system. Means here temperature will be more, and class 2 subsection 3 is emergency core cooling system for safety. And your third one, class 3 component is ND, various system for normal plant operation. So we have divided so many components of heat exchanger, subsection NB3, subsection NB2, NC, and ND. So according to that, material will come, it will inspect, and it will do. Okay, so this is standard one followed by all over world, means while manufacturing this heat exchanger. So this is actually our one of small job. So you can see that this is tube sheet, which one is very thickness, and this is shell assembly. At the end of the day, this equipment is looking very small one, but what are so many activities are involved, what so many checks are there for preparing this heat exchanger, you will come to know in later stages. This is channel cover, this is channel head, primary head, tube sheet, and this is shell assembly. Tube sheet is having thickness for some heat exchanger is 150 mm, and it can vary up to 350 mm. Okay, and next, this one is saddle support. So how flow path used to be there for means how heat exchanger are designed for manufacturing. So flow path, I will yeah. So there are three steps are there, means three parallel activity we can do. One is shell fabrication, you have just seen, and second is tube bundle fabrication, and third one is primary head fabrication. किसी को कोई दिक्कत है क्या, मतलब कुछ मैं ज्यादा फास्ट हो रहा हूँ, स्लो हो रहा हूँ, कुछ प्रॉब्लम है तो कोई बता सकते हैं?
No, sir, it's going seamlessly, sir. Perfectly fine.
Okay, thank you. So see, this is shell fabrication. So first plate will come, rolling plates will come, then we have to do longitudinal seam welding, and then dish end welding, dish end used to become, then nozzle welding, and then saddle welding. This is shell part. Main critical part is tube bundle fabrication. Shell fabrication, we don't require dust free enclosure. Dust free enclosure we can say, or we can say clean room. So dust free enclosure and clean room are tube bundle fabrication. This activity we have to do in clean room. Clean room is also called a dust free enclosure, and this primary head fabrication also we can do in normal shop. Just we have to maintain, suppose another one issue was there in nuclear heat exchanger, that we have to keep SS fabrication area safe, one side, and one side is CS, carbon steel cell. Suppose for example we are drilling. If suppose with the same drill we will drill carbon steel, and then same drill we will use in SS steel, then this also is not acceptable. Whatever the fixtures, whatever the tool we are using for SS, it should be separate, and it should be used for SS only. Means the fabrication area for SS shall be separate, for carbon steel shall be separate, to avoid any oxidation in the layer in the SS material, so that it will reduce the life cycle of the equipment. So this tube bundle fabrication, tube bundle, by the name you can see. First is tube sheet cladding. What do you mean by cladding? Suppose my tube sheet is carbon steel surface, and my tubes are inconel alloy. So inconel means special type of anti-resident tubes are there. So tube sheet is CS, and this is inconel. So in the tube, so once you will insert tubes in the tube sheet are drilled tube sheet. So you have to fuse the welding will tube to tube sheet welding is activity is also there. Means while after inserting tube, we have to weld the outer surface of the tube with tube sheet. So if tube sheet is CS and this is inconel, so parent metal and base metal are different. So we have to do cladding on the tube sheet surface of the inconel alloy from 6 to 13 mm in heat exchanger normally we used to do, so that fusion takes place during welding between tubes and tube sheet. So after cladding we have to do heat treatment. You also know that. Then after heat treatment, that tube sheet drilling, this drilling is very critical activity, and baffle drilling, because it will take so much time. And in drilling, we have to drift. I don't know whether you know or not. Drift is nothing but, suppose front side coordinate is x1 y1, and opposite end side you are drilling hole. Suppose that coordinate is x2 y2. So root over x2 minus x1 whole square plus y2 minus y1 whole square. So drift is shifting of the coordinates while drilling from first hole to back side, because it's not like that always that drilled hole should be and this tube sheet drilling we used to do horizontal drilling, because as the tube sheet thickness is 150 to 350 so we have to do horizontal drilling. When the thickness of the component increases, we have to do horizontal drilling. Baffle drilling normally 12 to 13 thickness, so we can do vertically. So but vertically drilling drift is not the drift, we don't have to worry about that, because for horizontal drilling drift is the issue, because drawback of horizontal drilling is drift. For baffle drilling, okay, means vertical position drilling, there we don't have to measure drift, only positional accuracy we have to measure. And in the tube sheet drilling we have to see both drift and positional accuracy. Positional accuracy means what? Positional accuracy, suppose we have take one center point, 0 point in the center, any you just imagine, and suppose you have given command for to drilling x 100 y 40 so instead of going 100 it might get 99.996, or y means we will give command to machine, some error will be there, means nobody is 100% perfect, so some error may be there, so it will go somebody less, it may go beyond more, it may go less, so that is the called positional accuracy, and it should be less than 0.1 per hour, 150 for our this heat exchanger requirement. And tie rod spacer, tie rod nut machining, tie rod is nothing but for after inserting tubes we have to tie rod spacer for adjusting that tube bundle. I will show later on picture. Next is anti-vibration flat assembly. What these are? These anti-vibration flat assembly. Why I have chosen this topic? Because in this heat exchanger, in this present scenario, earlier BHL used to concentrate on thermal power plant only, but nowadays what happened? No thermal power plants are there. Everybody want nuclear is though dangerous, but it is clean technology. So presently in the market, we have to follow with the market. In the market, what is going? Nuclear, defense. If somebody wants to do good business and they want good earn profit, so they have to this defense industry is one of the best industry, and then your nuclear power plant, and like this you will get good money from your customer, but at the same time they want very stringent requirement. In thermal power plants, very stringent, no, they are not very stringent. State electricity board, they will say okay, you as per drawing we have to follow, and we used to give. But now a market is there, so we are also shifting from to nuclear power plant. So that's why this anti-vibration flat assembly, what in this for anti-vibration is very thick SS plate. For machining of SS plate is a difficult task. For CS surface, we don't have means very within very less time we can do machining. So anti-vibration flat assembly only in India. This anti-vibration flat assembly, Fiat Italy is there one vendor. He used to give machined plates, means 3.8 and then slotting and machining operation used to be do. But presently in India, only one vendor is there who from 5 thick machining plate, he used to do 3.8 machining and slotting machining. L&T has developed that vendor. What BHL Trichy used to do for this anti-vibration flat requirement, we used to procure plates from Italy. Italy used to give 3.8 plates, and then we used to give slotting and machining. But L&T has developed one local vendor. He is the only vendor. He is the only vendor from 5 machining plate he used to thickness maintaining 3.8 mm, and then slotting wetting. He is the only vendor. So if somebody want to do a startup also, so so many equipments, critical equipments are there in nuclear and defense, so they can go for that. For this equipment, very few vendors are there. I mean, you can count in fingers how many manufacturers are there for this type of equipment. So that's why I have presented this one. And centering piece assembly, this is for FMRC, BCL, regenerative cooler, SDC, shutdown cooler, MHE, monitor heat exchanger. These are the various types of heat exchanger name. I will tell in the next slide. Then tube bundle assembly means we have to insert the tubes with the baffle and tube sheet. Whatever we have drilled, then and then after bundle assembly we have to do tube to tube sheet welding. I was saying that welding, why you are doing cladding for this welding only for suppose in CS surface is there in cooler. Then only welding will not stop. After this welding, we have to do helium leak test of this welding, whether our weld joints are good or not. Means if any single joint is there, then whole job can be rejected, or we have to rectify it. So that's why it's very that tube to tube sheet welding we have to do in automatic orbital welding machine that used to got. This is a, and this welding we have to do in clean room. Normally thermal power plant we used to do manual welding, and that too also in general without maintaining any atmosphere. And then we used to do for helium leak test. Helium leak test over, then expansion of tubes. Expansion of tube means for locking tubes to tube sheet, we are doing two steps. First welding and then expansion. Both are for locking the tubes inside tube sheet. Then after expansion, then saddle welding or tube sheet. And this primary head fabrication is there. Initial machining, nozzle welding, partition plate welding, final machining, saddle welding. This is end part. So this is the heart of the this nuclear power cycle heat exchanger. These activities. So tube bundle assembly in clean room, welding clean room, expansion clean room. So these three activities we have to perform in clean room with strict maintaining temperature, humidity, and particle count. Particle count means not a 0.5 micron, 5 micron particle should not enter that clean room. That much close should be there. Means we have to keep AC, means for maintaining refrigeration, means for maintaining the temperature, humidity. We have to use HEPA filters for capturing any particle. If suppose came inside the clean room, it should be closed. Once this activity starts, we can't open the door in the closed condition. It should be there. If suppose any man came from outside and he wants to go, he has to use air shower. Air shower is nothing but once you will go, blow of air will come, so not a single particle will be there in your clothes. So that much accuracy and that much cleanliness, that much we have to maintain for this tube bundle fabrication. Next side is after this shell, and we have to do another so many tests are there. This shell side air hydro test, shell side hydro test by water we will do, and helium leak test again after hydro is there for RGCL only, regenerative cooler heat exchanger. Then tube side air hole test, tube side hydro test, and after hydro it's not like that. After hydro just painting, we have to dry it heat exchanger, not a single droplet should be there. Then this ball pass test, what we do, we are using U tubes. So in the U tube, from one starting point, we will send ball. That ball should pass on and should come from other end. If suppose any undersized tubes are there, or any obstruction is there, or any contamination or chips is there, that ball will not come. Means one gun used to be there, small gun. This is called ball pass test. And then eddy current testing used to. Eddy current testing of tube, most of the time, if any scratch will come in tubes, that our tubes will fail in this eddy current testing. Means very critical. Means that's why we have to use gloves while inserting tubes. Eddy current testing of tubes, Normally in thermal power plant, eddy current testing of tubes we used to do before manufacturing, but here after manufacturing also we have to do, because during manufacturing any scratches are not there. Otherwise, because thickness of the tube is 1 to 1.15 mm, it may fail. Then after that final assembly, some bolting joint will be there. Then again tube side helium lift is there, and then again cleaning and painting in is there, and nitrogen filling. Then we will hand over to our customer for inspection. But customer will witness each and every activity, even drilling, everything. So next slide. This is what I will call that saddle support structure with shell welding of this welding. Normal welding we can do. Only consumables, whatever the consumables are there, they that our customer means NPCL has, we have to follow ASME's guidelines. Which consumable we will use. Consumable, we also batch testing is there. Then only we can use consumable. For that, our welding technology is there. They used to prepare welding procedure specification. For in this nuclear industry, for every welding there should be separate welding procedure specification. So for that welding procedure specification, what consumable we will use, it will be specified, and it should be witnessed by customer before using for welding. This is support structure welding shall be done in stacking condition in RGC, regenerative cooler, and BCL, bleed cooler. We have stacking of heat exchanger, means double decker. Also in local we can say double decker. So two tube bundles are there. So that two tube bundle, it will be joined by interconnecting pipe set. Next, so I told you cells. This is shells are normally rolled from plates. Layout marking we have to do for before. The marking is the before. Then we can do cutting and weld edge preparation for long seam. For RGCL we are using forged cell, because wall thickness will be more for RG regenerative cooler. Forged cell have better dimensional accuracy, ease of fabrication, and elimination of longitudinal well in RGCL. So plate can be anything, cold rolled or hot rolled, depending upon the thickness. After rolling, edges of sur seam welding are prepared, planing machine or seam grinding machine. Shells are after welding also, cells are re-rolled to correct any distortion, if any. If sometimes distortion is there, so we have to take care for that also. So in the shell assembly, that ovality we have to because if suppose shell ovality is not there, then tube bundle, means with tube sheet, tubes and tube baffle. This is called tube bundle and shell. We have to insert tube bundle inside shell. So ovality of the shell is very, very critical. So it should be maintained as minimum as possible. So what will means means clearance, whatever the clearance should be there, it will be the difference of the OD of the baffle and ID of the shell is very less. So we have to use for shell assembly special jigs and fixtures for maintaining less ovality. And some precautions are there for while manufacturing this shell assembly. This clearance, normally 2 mm is there, shell ID and sliding rod on baffles. Ovality and straightness also should be maintained. And proper sequence of welding to be decided for each welding joint. Means whatever joint is used to be there in the welding process specification, the sequence is mentioned, which welding joint should be do. And this welding should be carried out by experienced person. It should be certified. And proper storage and preservation. And this is called tube bundle assembly. I was speaking. This cladded drill should, I already told. Baffles with sliding pin. Thermal baffle is there. Thermal baffle size is little bit more. Tie rod, spacer tubes, tie rod nut, SS Incoli 800 tubes. And this anti-vibration are used for this. Already I told that. So that skeleton means ढांचा, मतलब ढांचा तैयार, मतलब skeleton we have to prepare for tubes before insertion. So that skeleton assembly will be inspected, used to be by customer. And this when we are preparing for bundle, we have to that our tube should be cleared by customer and verification of YouTube. And it's not like that, suppose tube sheets hole are there, we will use original tubes. We should not use original tubes. First we used to do dummy tubes, we used to keep, we used to insert that. If suppose no scratch is there on the tube, then means hole is okay, we can insert tube. But suppose if any scratch is there, that means some problem is there in the hole, so we have to clean the hole. We have to check with video scope. Video scope, each equipment is there, that is called boroscope something also, that is we use for inspection of that type of holes where human can't go, where human eye can't see. So one that what one cable used to be there and one camera front used to be, we used to insert the tubes sorry, insert in the tube sheet, and we see whether any hole there hole or not, we have to check. And then tubes are packed individually, means whatever that sequence in the drawing is there, they are packed individually in a sleeve or row wise. Thus, and the whatever the tubes bundle we are using, packing also means whoever the tube manufacturer is there, they used to packing in we used to give instruction, you just send tubes in the same manner as per drawing, as per requirement, means whatever row or column number tubes are required, he will pack in that that box only. That box also we have to open in clean room only, means in dust free enclosure, we can't open the box outside. Okay, tube and that are unpacked at the time of insertion only. U-tub insertion as per sequence, we have to follow the sequence. This contact rolling after insert the tube. Contact rolling means contact rolling nothing but expansion only, but here we used to do two types of expansion. One is contact rolling, one is full expansion. Contact rolling is done for welding, means temporary joint we can call, means little bit expansion of the tubes with the tube sheet, so that it will be locked, means position of the tubes will not move while TTS welding, tube to tube sheet welding we call. So that's why contact rolling we used to do. And that DFE means dust free enclosure, and DFE clean room is whatever the atmosphere is there, it should be cleaned by customer. We have to regularly, I already told you, cleaning we have to maintain after drilling, cleaning tube holes, tube sheet baffle. And for suppose SS component, what we used to do, if suppose we have done machining and it used to stay for so many times, then some layer used to be there in the SS component. So we used to do pickling and passivation for preservation of that SS component before using. And proper fixtures kit shall be available. Proper alignment of tube sheet and baffle holes for smooth tube insertion. Means alignment also for this alignment by the terminology alignment, you know that for alignment we have to use optical alignment telescope. This is a very this is simple telescope, you have seen that microscope and like that. This is alignment telescope. We have to focus, suppose tube sheet hole we want to focus with, so many baffles are there. Baffle tube sheet is one, baffle used to be 19 numbers, 14 numbers. So every tube sheet to baffle joint, we have to align it with the alignment telescope. Alignment telescope is a that instrument used to be there, and this telescope used for in gun drill manufacturing, in aviation sector and defense, because we have to see whether that for drift also, I was talking about that drift, how we will check horizontally how much drift my machine is producing. So for that drift also we are using optical alignment telescope for measuring drift. In the ISRO, DRDO, for the critical equipment, they are using micro alignment telescope of the holes in their components, whether the drift is not. So for us, we are using alignment telescope in our heat exchanger for alignment of the tube sheet and buffer, and then our drift. So this, I already told you what you have, you should be handled with gloves and 100% dummy tube in each and every hole. we have to first insert dummy tubes, then we have to see whether any scratch is there. If scratch is there, then we have to look out what's the problem. We have to use industrial video scope and we have to see. If no scratch is there, we can carry on our original tube insertion. So this cladding procedure qualification and tube sheet cladding, I was saying you that CS surface is there and we used to do cladding. So this is the cladding. We for around 6 to 13 mm, we used to clad the surface. After cladding, only drilling will take place, and drilling, then we can tubes we can insert. So this is the cladding. For that also we have to first qualify in. We have to qualification round is there for like this. That operator has to qualify in dummy plate with cladding. If suppose in dummy, in the nuclear ASME section 3, they used to say that you have to qualify whatever the job you want to do. You first qualify, qualify operator, you first qualify machine, and whatever you will do, you should have written guidelines. It's not like that. Normally in thermal power we used to see drawing. Okay, drawing we used to do manufacture and QAT. But here what, every step, manufacturing process plan, engine design, or ASME, we have to, for doing each and every activity, for designing anything, or for manufacturing, or for welding, or for any heat exchanger, this we have to written guidelines should be there. Means we have to inform that okay, we are doing ball pass test. For ball tester, how will we use, what size of ball will be there. For welding procedure, welding procedure is there. For tube sheet drilling procedure used to be there. And for baffle drilling procedure is there. For all critical activities, procedure qualification is critical here. So this cladding, I already told you, application of one material over another to provide a skin or layer, providing welding compatibility between two non-compatible material, increasing corrosion resistance of base material, because we know CS they used to corrode. So for increasing the resistance, we are using cladding. So cladding can be submerged arc strip welding or shield metal arc welding. Any welding we can do. So tube sheet cladding requirement. This is inconel tube, and this is CH forging. So we have to clad it with inconel. Then only we can insert this tube. So the tube material used in heat exchanger. This is a standard. Generally we called as Incola 800 the tube. Tube material not that welding is not recommended as weld defects may be present. That welding, that's why because both are not compatible. The solution to this is compatible with both tube sheet and tube material. Inconel cladding, that is called Inconel 600. Whatever the cladding we use in CH forming, we call Inconel 600. That I already told. For cladding, what required? Cladding operator qualification, procedure qualification, and consumables, whatever you do, batch qualification. So that is the process. Coated manufacturing welding electrodes and bare wire rod strips. Two types of consumable are there: small and SAW. And chemical analysis, tension test, bend test. For this strip and electrode, consumable, radiographic test, impact test, hot crack test, micro
पंकज लोग आज निकाल रहे हैं बोल के मैं कल इन लोग भी बोल डाला था
micro hardness test. So this type of so many tests are there. Before welding, we have to do so many batch tests, consumables. Then only we can go for welding.
हम लोग भी फाइट किए उसी दिन, मैं भी थोड़ा सा बुरा लगा, मैं भाभी.
So this is cladding procedure qualification.
क्या इन लोगों को कौन से बोल डाला था?
सर मयंक सर कुछ प्रॉब्लम है क्या? एनी प्रॉब्लम? हेलो
ये वही वाला क्या सर्टिफिकेशन वाला 3 दिन का बताओ ना, लिंक इसका ज्वाइन करने देगा मेरे को.
Sir, I have forwarded this issue to our technical team, sir. It will be corrected soon, sir.
हेलो, माय वॉइस इज ऑडिबल?
Yes, sir, your voice is audible.
अच्छा, कुछ बैकग्राउंड में चल रहा है, मैं रोक दूं क्या 5 मिनट कुछ?
No, sir, no, sir. Everything is all right now, sir.
Okay.
Sorry,
The
sir.
cladding shall be okay, no problem. Cladding shall be corrosion resistant. The cladding shall be specified chemical composition. The cladding, suppose we are doing cladding, we should not any crack is there, bond should be lack of bonding proper should be there, bead should be there, proper this under bead cracks should also be not there, hot cracking also be not there. This cladding is very critical activity. It's normal operator, normal person can't do. It means very difficult. Means before doing production, we used to do simulation. This is qualification procedure, already told you. And this is undiluted chemical composition for 2 mm depth. This should be the composition of the cladding. So it's not like that 6 mm it will do in single place. It will do in 2 mm, 2 mm like this, 6 mm. It's not like that 6 mm, first 2 mm it will clad, then second 2 mm, then third 2 mm. Minimum 6 mm cladding we used to do. So this is cladding procedure going on. And sometimes cladding, this plate will come topwards. We have to control temperature, interpass temperature, post heat temperature, flux, travel speed, and what will the parameters for this welding. Cladding procedure qualification. So this we have to temperature. This in WPS welding procedure specimen, it used to be maintained. Chemical examination, bend test. This is spectrum machine we are using for bend testing. And test metallographic examination also is there. Hardness also we used to measure. Hot crack test. Okay, so this is that thickness maintaining. This is repair. If suppose repair is there, we have to do that for repair also sometimes. So this is a test coupon, how welding used to be there. We used to maintain record for that. This is operator who successfully automatically qualified, means whoever the operator is there, once qualified, he can do his job. This is our tube sheet now, actual tube sheet where we used to do cladding. After cladding, we used to do LP. Then whether any defect is there, whether any pores is there, or any particles are there, then it is ultrasonically test also. Means these ultrasonic for ND qualified persons are they used to be ND qualified, non-destructive examination. So they used to do both these tests. Then only after this will qualify. I will just take 1 minute break, just 1 minute.
Sure, sir.
मेरा हो जाएगा 1 घंटे 1 घंटा हो गया बस मैं खत्म कर हाँ जा हाँ yeah I came back. Okay, so these are the defects: porosity, distortion, micro crack, poor fission. I already told you. While cladding we have to see. Then after cladding, stress relieving, I already told you. And this after stress relieving, we have to do tube sheet machining. You can see that this is vertical boring machine. Before drilling, we have to do machine whatever the profile of the fine tube sheet we required. We used to do machining. Then second, heat treatment. Heat treatment normally we used to do, it should be gas fired or electric. Oil furnace is also there, but because this sulfur means this sulfur we have to see in each and every activity, so that's why oil fire furnaces we are not using. This heat treatment we have to maintain whatever weld, suppose that weld joint is that shell joint, big joint, we have to see whether we have to heat treat it. Heat treatment we have to do. Now this cladding over this another critical activity, drilling qualification and tube sheet drilling. So these are so many holes. Suppose in this heat exchanger around 8 holes are there. So these holes we have to do procedure qualification, operator qualification, and QAP stages. This is the whole tube sheet. So this you can see we have fixed the tube sheet with the clamps, and then we have to these holes are there, and one by one hole, this is a marking, boja marking, we call boja marking. And it should be that horizontal drilling should be done. We use in deep hole drilling. That vertical drilling, horizontal drilling is called normally deep hole drilling. As the size increases, we have to use deep hole drilling, not drilling machine, vertical drilling machine. So we can do rifles and like this. So whatever the that 0.1 means parallelism of the block shall 0.5 mm. It should be straight. Drilling of here also drilling, we have to trial holes on mock-up, and we have to establish the parameter. We have to do in the job. We have to do some trials. We have to do with fixing the parameters. Then we can do. So normally for establishing parameter or operator of 50 holes, we have to do dummy in side job. Then this actually will happen. And the tool life is also very critical parameter. Suppose I am giving you example. Suppose one drill tool life is there. It's 100 holes. So we have to establish the tool life. It's not like that we can use the tool as much with our means anything. Suppose I will establish procedure qualification. This my tool can do hill perfectly 25 holes or 50 holes. For actual production job, automatically that drill we have to change after 25 holes, 50 holes. It's no means it's not like that jugaad. We have to follow the guideline. Whatever we have done in procedure qualification, we have to follow in actual. Normally this is the critical path activity. Means drilling, we used to think that drilling is simple, but for this nuclear heat exchanger, this is the most critical path activity. So such a 3-meter machine is should be there, X, Y, and Z, and for positional accuracy shall be 0.01 n. Means this the heat exchanger are designed that 0.1 accuracy should be there. 0.1 accuracy shall be there, positional accuracy. So our machine which we are using, which it should be less than 0.01. Then only we can maintain 0.1. So that's that much accuracy machine should be there, because the heat exchanger are designed for 0.1 mm positional accuracy. So machine, whatever the machine we are using, calibration, it should be calibrated. See, this is BTA, BTS. This is new technology. There means body will be there. British Trepanning Association we call BTA. At insert we can, so you can new drill. In gun drill previously what used to be do, suppose 50 holes will be there, then we will remove gun drill and then we will do grinding. So grinding we will achieve that dimension. But in BTA one advantage is there. See, we will drill how much hole, then after that we can throw away. It's it can't be reused, one time use. BTA advantage is there. Optical instrument, I told that alignment telescope used to keep targets are used to keep. Suppose we have to align 2 points, we will keep at 1.1 target, at the end second target. Bore dial gauge normally we use for measuring diameter. Vernier caliper, you might be know that. Go, no go, go bar gauge check. Go for you also know that about that for measuring. Surface finish measurement, one instrument used to be there. They used to means that machine used to cover how much surface finish is there in the hole machine surface. So ligament gauges is also there. Ligament is about that surrounding 2 holes distance. Angle plates for holding that tube sheet beside the machine. Dial gauge, clamping device, coolant and optical tool. I already told that alignment telescope. So drilling procedure qualification, I told already, spindle feed, pressure, temperature, tool life, we have to establish. And whatever the qualification block we're doing, it should be of same material, same heat treatment, and same ending. Means suppose the manufacturer is making tube sheet, so they have to provide one small blocks. Means they have to manufacture with the same heat treatment. Means it's not like that some other block we can test by. Whatever the original block will come with that original block, one small block will also come for procedure qualification or for mock-up. So this like that. We have rigid clamply, drilling quality 50 holes. This ligament hole position drift. I told you that what is drift. Visual finish should be good. Otherwise, what will happen? Suppose we will insert tubes, scratches will come in the test. Our tube bundle assembly may fail. So from starting from each and activity are critical, so that at the end good product will come. So no rejection of the job. So whatever this telescope I was saying, that this is the alignment telescope. This is the drilled. So, front he will put in front, that target used to be there, and then at the other side of the hole, target we used to keep this target are there, front and second. These are the markings on the there. Then we can find out the drift. Means whatever the coordinates had shifted from front to end. So whole dia we can use ligament here, whole position alignment telescope I told, and whole drift telescope. This is okay. This is the bore dial gauge. These are the targets, and these targets are fixed on this target holder. And visual boroscope is I told that industrial videoscope. This is one used to be wire used to be there, and front camera, so you can see inside tube. This is surface finish test. Now see that much big used to be machine should be there, and this is the tube sheet drilling gauge carrying on. So this is the mock-up. Means the daily operator will come, he will try first here, then he will actually customer will see that okay, hole is good, your parameters are fine, then we can start drilling. So daily, due to shift of change or due to operator or any problem arise during drilling, first we have to do in this, then we can go. Even though operator change, suppose in first shift operator came, he will drill, then second shift another operator come, he will also drill here first, then only he will touch actual job. Because huge rejection is there. Penalty is also used to be there if suppose any hole or tube plugging used to be there. We are avoiding tube plugging. Customer also don't want tube plugging. Tube plugging means if suppose any hole or anything happen, we have to plug the tube. That hole should be plugged. So normally designer used to keep 2% of the hole plugging. He used to give tolerance, means maximum 2% of the hole should be plugged. This is the tube should production job, and like this we have to do tube sheet drilling. Here mock-up is there, and drift I already told you. Visual finish, go drill entry and exit for hole dia and ligament. From both sides we used to keep gauge check. Suppose in front side hole size, here another interesting thing I want to say you. Suppose 150 hole is there, so he used to say that your dia side at the middle at the end. So how much thickness of the there minimum at 3 location we have to check the dia. And normally heat exchanger for our power plant, normal power plant, we used to measure only just dia. We don't check at here we have to divide the thickness. Suppose 350 thickness is there, we have to divide it into 3, and for each position we have to check the dia. And this is drilling tube sheet. Already I already explained you, parallelism shall be maintained 0.1 mm. So for in the machine we have to check oil temperature, oil pressure, cooling, leakage, no leakage should be there, dial gauge are available or not. Start of shift I told, changing tools before drilling, we have to check. And we have to check the program also, what is the CNC program, whether it is correct or not, whether drilling pattern is as per program or not. Everything we have to verify. Program verifying also there, program verified, everything we have to verify. how changing tool register also we have to maintain how many tools you are using, what type of tool, because suppose we have we have qualified for 50 holes, so we have to in production also we have to use tool for 50 holes only, then we have to change the tool. For that we have to maintain tool register record. So this is video scope. We want to see any intricate surface where human eye or our approach, human approach now do. So we can use this. This is called boroscope and industrial video scope. Here in the screen we can see what is the defect. Normally during ball pass test we can see why ball pass test fail or why scratch in the dummy tubes came. We can see here. So whole drift. This already I told you. So this type of errors used to see front hole is good, but inside hole is not due to tool breakage, machine trip, excessive tool wear, temperature variation. That's why we are doing qualification to avoid any problem came in actual production job. So cleaning in preservation. Suppose we have drilled tube sheet, we have to clean it, and we used to keep plastic cap because heat exchanger contains of so many components, so we have to by the time suppose our drilling over for next we have to preservation should be there for all components. Suppose in our tube we plastic cap we used to keep. And baffle drilling, normal drilling machine CNC vertical drilling can be used, but okay, we can use horizontal drilling, no problem. So here baffle drilling are very thick plates. It's 12 mm. So by stacking also we can do the baffle drilling. So these are baffles. These are baffles. So this is our clean room condition where temperature, humidity, and particle count is. See how much clean it is. So tube insertions is carrying on the whatever the picture I am showing. This is skeleton, tube skeleton. We are doing this. So tubes are inserted smoothly. So like this is tube bundle insertion activity is going on skeleton. So we have how much cleanness is there. We have to maintain tubing is in progress. So one tube. This is one bundle. This is second bundle. U tubes are there. So this will go like this around 8. This is small one. 8,000 holes heat exchanger are also there in nuclear primary site. So this is tube to tube sheet. The welding joint I was speaking about that. So this is the orbital automatic welding machine. This is also programmed. This parameter. So see this weld joint we have to check. Then only welder will qualify. So tube to tube sheet welding, we have to do sufficient trials before trim any blur, or we have to remove that weld edge preparation. We have to weld edge prepare, then only we can do welding. See, this is the tube to this is the drilled hole. And after this welding tube to tube with that machine, this joint, this will also be done in clean room condition. That much finish should be there. And this is called, I was saying you, expansion of tubes or contact rolling. This is tube sheet, and this is a tubes. This we are locking these tubes in the tube sheet. So expansion are there by using mandrels and rollers. So expansion after expansion also, whether dust, dirt, or foreign particle or any scratch is not there in the tube. This is primary head fabrication. That one is for primary head. And tongue machining is there on partition plate. After welding we have to do with primary head. And this is a hydrostatic test. This shall be carried out after expansion of tube. All welding activity should be completed before cell side hydro test, and some specification are used to be there at what temperature. Whatever the water we were using for hydro test, it should be less than 20 halogen. Hydro test, DM water I already told you. Helium leak test we have to do for tube to tube sheet. Whatever the weld joints we have done, we have to do helium leak test. After hydro test, we will do helium leak test, ball pass test, then ECT of tubes. So critical point are ovality. We have to maintain cladding, drilling. These are critical. Tube bundle assembly, clean room we have to do, and SS material we have to shall be carried out in clean area. All SS items shall be pickled and passivated. I already told you. So this expansion of we used to buy mechanical rollers, automatic hydraulic also came, but in nuclear power plant we have to step using mechanical rollers in stage by stage expansion, 30 mm, 30 mm, 30 mm, like that. We have to do expansion. So tube bundle insertion I already told you. So normally in primary cycle heat exchanger, these 6 type of heat exchangers are there. This shutdown cooler, bleed cooler, regenerative cooler, FM return, fuel metering, return and recirculation cooler, inventory addition, recirculation, supply cooler, moderator heat exchange. So the that so these type of 6 type of heat exchanger are used in primary cycle heat exchanger. So this moderator is very big one, 8272 holes. This is the 2 meter job. This is the very big job. This one. So for suppose in one power plant, if suppose we are manufacturing this much hole, we have to means that much tubes required and that much holes are there per tube sheet. So thank you all for listening patiently this heat exchanger, nuclear primary cycle heat exchanger. So I just want to share another slide. This see this is our big that moderator heat exchanger final job, and this is the our reactor core, and this is RGCL bleed cooler. See this reactor, this is uh, primary containment. I was called a primary cycle heat exchanger. So whatever equipment we have to maintain, we have to follow with strict guideline. And this is outside this, whatever equipment is there outside this turbine, and that much accuracy not required. But since this is the reactor core equipment, so moderator is here, shutdown cooler is here, FMRC is here, reactor core is here, RGCL is here, BCL. So that's why, and this is steam generator. Steam generator used to be prepared by BHL Trichy. So that's whatever the components inside here, we have to this is called primary cycle heat exchanger, means cycle equipment. So we have to carefully we have to do it. And like this I will, this is moderator here, 3D diagram, any we can do it. And this is just basic features, not very heat exchanger. What will the OD, ID, length? So like this used to, regenerative used to be like this. This is channel head, your, and this is double decker cooler. I explained you bleed cooler. And see this is your nozzles are there, process water in, process water out. So this is drain. D2 also used to go in, and D2 goes to out. So this is your tube sheet, this thickness, like this is saddle support. And this is another view. See this after tube insertion, these are baffles. So these are anti-vibration flat, जो very 3.8 mm thick plates are there. So this we have to maintain it for locking for the, and no vibration during inside the tubes. Like this. This is a cut portion. So here cobalt restriction in the tubes, nuclear industry, they will restrict the cobalt to very minimum. Means maintaining this less than, it's very difficult. Means it's a very difficult task for tube manufacturer. And this the specification of what various components are there. The Forstner's liner plate, cover plate. This is the tube sheet, and this is 2-9 support. We used to do it like this. Spiral gasket we used to do, spiral wound gasket. And this is the anti-vibration flash that strips 3.5 for supporting anti-vibrations. These are also anti-vibration by using TIG welding. This TIG welding. So this is the tube bundle. Critical point weld drift, I already told you. Radiography of weld joint also. And bolt tensioning, we have to use hydraulic bolt tensioner. Means how much torque we are applying as per requirement of the how much load it can sustain. So these are the anti-vibration dust-free enclosure. It shall be ISO class 8 in operation condition. So when we that shop, suppose any clean room manufacturer is there, we used to say that you prepare ISO class 7 in built condition. Means while in operation requirement is ISO class 8. So at least in built condition it should be ISO class 7. So as much class is reduced, that much is difficult. Suppose your operation theater, whatever the clean room condition is there, ISO class 5 or 6. So, and your pharmaceutical industry, they used to maintain ISO class 7 operation 5, 6, and that dust for this manufacturing of primary cycle heat exchanger, we have to maintain ISO class 8. Ball pass test detail, eddy current here. This is the features of dust-free enclosure where we have to do tube bundle insertion or active number of cycles, and temperature should be maintained 24 to 20, and welding will take place. Thank you to all of you. Actually, with the very last time, I tried to share my experience. So presently, I am working in this for BHL Bhopal is doing first time this primary cycle heat exchanger. So I am looking after this technology division only. So I try to share within whatever time available to me. So any questions?
Thank you so much, sir, for such a novel and mind-broadening session. Now let us move towards the Q&A round. And for this, I will request you all to please ask your queries, or you can write it on chat box also.
A very good afternoon to you, sir. Sir, I
Yes.
have a question.
Yeah.
So, what is the scope of thorium-based power plants, sir? Since India is abundant with thorium,
Hmm.
so
Yeah,
sir,
yeah.
what is the scope of thorium-based plants in India in future?
See, actually, this thorium power plant, actually, that BARC, it has not, we are whatever doing, that is commercial one, Nuclear Power Corporation of India Limited. So thorium-based power plant is under research stage only. Scope is very more. Whatever this design technology, this is there, that one Russian or American one. So BARC is developing, but that one is not commercialized now. So scope is it is in the R&D stage only.
Okay, sir. Thank you, sir.
Good afternoon, sir. Sir, I have a question. The parts of heat exchanger are selected using the sampling method, or they are inspected individually?
Inspected individually. See what so many parts are there. Suppose baffle plate, means stage wise inspection right from the raw material. It used to be there. I mean, before drilling, after drilling, before cleaning, packing, and after painting, and after before dispatch. Thousands of inspection stages there. Ball pass test. Means it's endless. Even though whatever the we are using, we have to test it for each and every component used to be there. And that you are saying simultaneously, if suppose hydro test we are doing, any leakage is not there from the tubes, like this we are. Hello. Okay. If
Okay, sir.
anything,
Thank you so much, sir.
anything more is there, I will share my mail ID. So you can share. You can all take that, and if suppose anybody want to do research or anybody want to do 3D programming, so they can get topic or whatever the practical issues we are in shop. I can share, and we can come out with solution or some better solution, because we are also first time we are preparing this heat exchanger. Normally this type of heat exchanger used to came from outside or LNT. So as the thermal business is no more, so we have concentrated on nuclear. So if any questions or any project or some sort of there, we can share and we can get it. Okay.
Sir, excuse me, sir. Sir, there is one more question.
Yeah, 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 yeah.
From Kishore Kumar Sahu, sir. What
Yeah.
is fouling process in heat exchanger? Sir, please.
What is
Fouling
what is
process.
falling process? Means falling any that melting of tubes or any defect in the heat exchanger will came. Exactly, theoretically I know, I don't know, but means after we have किताब को छोड़े हुए वो हो गया उसका टर्मिनोलॉजी आई कांट से, बट फॉलिंग प्रोसेस इज दैट मीन ओनली any problem in heat exchanger came or tubes like that, that is called falling.
Thank you so much, sir.
Okay.
Now we have come to the end of this session. We would like to
Okay.
convey our heartiest thanks to Dr. Vinod Patnaik, sir, for such an exciting session. This was the supreme paradigm of why this kind of interaction is crucial. We are thankful, sir, for enlightening us. Sir, one last request, sir.
Yeah.
Sir, may you please share your PDF with us? It will be beneficial for all the participants, sir.
Okay, sure. Yeah.
Thank you so much, everyone. This session has been ended. We will meet you all shortly at the third session, that is exactly at 2:30 p.m. Thank you.